Good afternoon. Today we're going to look at a CIM computer interface module for a 1040 AMMPS 1040 generator, and this unit came to us from the auction directly from one of the government auctions. And the reason why we got this here is because this is another one which we're going to prep for our auto start system for these here. And you can see we haven't drilled any holes into this cabinet yet for this. So this unit was installed in one of the generators and had been taken out for whatever reason. And the problem is, as I showed yesterday in the pictures, is that little screw here with the gasket on there, that O-ring, that little tiny O-ring. And they go, the board basically, this here goes from the backside, goes in here from the backside. And then these screws sit in here like so. And you can see this, that these holes are slightly loud, they're a little bit recessed. And there's a gasket on the other side. And in this case here, on this particular generator, what happened is this screw here started to leak air. You can see this is coming from here, and it went into here, through here. So this is the top actually of the unit. When you look at this from behind, if you take it out of the generator, this is actually the top one, and it is the top left bolt. This screw here was leaking. And the way this actually works is heat attracts cold. And what we have today in the electronic world, this is a design of the 2000s, and you can see this is already done all in SMD parts. There's virtually not many through-hole parts left. Bridge rectifier, some diodes, and an IGBT, but everything else is basically SMD parts. And what happens now is you can see the amount of heat sinks you got on here. This is a huge heatsink which attaches to the rear on these two holes here. And you have even more heat sinks here at the CPU. You have a 3.5 volt battery here, which basically keeps the whole memory portion alive. This is a battery you need to check if you own one of them. You got more heat sinks here. You can see that all the other screws here started to rust. And the way this works is because of the heat attracts cold. When this unit operates, the LC display gets hot. So does the controller unit on the back. You can see this. There's another microcontroller on there with RAM and other and hard disk, solid state disks. And they get hot. They run hot. And the reason why this is, the semiconductor industry has gone over to produce primarily components for battery operated devices. Yep. Handheld devices, which means their target is an operating voltage of 1.5 volts or less. And you know, you got 24 volts normally in there. If your generator or alternator is running, you're probably at 26, 27 volts. And if you have 1.5 volt parts in here, or 3.3 volt parts, which the majority of them are, this is the main microcontroller here, and this is the solid state disk. That's basically contains the software. This runs all of this stuff, gets hot. Then there's another microcontroller below this thing here, an ARM controller, which gets hot too. And you're operating this, so you have to dissipate, first of all, 24 volts to 27 volts DC. You have to bring that down to 3.3 volts or below. And then the other issue is these parts draw tremendous currents because of the low voltages. As lower the operating voltages, as higher the currents is. And that's why they need these massive heat sinks for these small devices. We at Innova High Tech, we're trying to stay away from any type of devices which operate on less than 5 volts, just for this reason. And that's why a lot of our boards still incorporate through-hole parts that may not look up to date or as fancy as these things do, but they work a lot better, and you have less of these issues. Now what happens is these O-rings here have not so much their purpose is not so much of sealing actual moisture, water coming in there, you know, like rain dripping on there or sprayed water. What their thing is to get the cold air from moving in, because this thing heats up, and if you operate this, say, like below 45 degrees Fahrenheit, 50 degrees Fahrenheit, depends on what your dew point is, this thing will go over 125, 150 degrees in heat internally. It will heat up in any type of opening. Also, all of these screws here you see, if you ever take one of those out, except those ones here, they have a gasket underneath. But you can seal those with O-rings as well. That will go through every single screw. You're going to have the cold air entering it. And once you shut the unit down from operation, that cold air is going to condensate internally on the circuit board, and in the enclosure, as you can see here. It just starts to condensate, and this is what you have here. And that's how that oxidizes all around. And you can see where hotter it is, wherever the hot spots are, that's where you have the most amount of condensation of moisture. And that will go onto the circuit board. And I had to resolder 3 joints here because that will eventually eat itself through the solder connections and cause cold solder connection. It can disconnect the part completely, which then can cause further failure. But that's basically where it is at. And for those people who are interested in our auto start board, we have the size 18 shell mounts here. It's going to be next between J3 and J2, which is this lower corner here, and it's going to be a 1 inch or 1 3/8 inch connector, 10-pin connector, and you bring the wires then out up front, and they wire into the engine control switch on the commercial version and on the aux output for alarm mode, where we shut the whole system out. The control panel then is here programmed through the display to utilize the aux contacts in the system for alarm, basically the same or e-stop function. That means if there's any malfunction, it will shut down. And with that, the circuit board mounts below in the underneath the fuel tank and the fuel opening a fuel support door. I think that's what that is called exactly. And then you can run this whole system very nicely. But we will supply all of these O-rings new. These here, they're going to come with every kit, and we're going to put a high-grade siliconized rubber version of them in there. They will make sure that they seal, and we will also provide a template to drill into this here. And basically the way this is going to work is you're going to be able to just lay this in, and it will match up here and here on the sides. And then you have your center hole you can drill, and then the 4 mounting holes, and you can then tap this. I don't know what size that is. There's a number 6 or number 4, I believe it is, 4 size bolt screw with a rubber, and we're going to mount it from the outside because we need the clearance to the circuit board for the wires to get through here. This has proven itself out. It is just a whole bunch of screws which have to come out here, basically going around it. They have to come out, and well, these screws here too. But like I said, we will send you the O-rings with the stuff, so you will have a complete seal kit to get your unit properly sealed off, and that is also then written in the manual. So this is just to show you what this causes and how our circuit board system here fits in here. That wiring harness from here then goes down to our circuit board, and we have one wire running over to the relay board in the other compartment to the right and the lower right of this unit here. And with that, you have a great afternoon.